Okay, let's see how to trace this recursive code where we are told that we are given input values -23 and -48, and we are calling this function with these values as x and y, and we have to tell what will be the output. Now, before we start tracing, there are certain general rules to keep in mind. The first rule that we will keep is when we are tracing a recursive function, we will be drawing the stack frames. That's how we will go and do it. So stack frames have to be taken into consideration. Second thing keep in mind is wherever we are having a return statement directly, so what we will do, we will assume that before this return statement there is an assignment. So that means this will be a equals to the answer of recursive call, and then we are returning a. So treat this as two statements. One is a is equal to minus being 0 recursive minus x comma y. So that means we are assigning the result here, and next line we are saying return a. So I'll treat this as two statements rather than one. Same way here also it will be like b is equal to this answer, and then we are returning b. So this value will treat as b, this will treat as c, this will treat as d. This will help us trace it with ease. So two rules keep in mind, and then we will go and look at a smoother tracing of recursive functions, right? So let's write these two rules so that we can follow them rigorously. All returns are treated as assignment plus return. This is what we are going to assume. Now let's get started with these two rules. Now first time when this function is called, these are the two values that are being passed. So let's draw the stack frame of that function. And stack frame of the function contains the input parameters, the values that we are getting in. X is this, y is -48. And that's where our tracing begins. And in stack frame, we also store the local variables if there are any. So now we go inside the function. Tracing wise, we look at the first line and see what is the impact of first line. So first line is saying if s is x is less than 0, which in this case it is, then we are going inside this if condition and we are going to return something. As I said, this return statement we will treat as two statements. So I'll say a is equal to this answer that we are putting in a, this has to come recursively. Here there is another recursive call happening, right? So that recursive call that we are making, let's go and draw that recursive call stack frame once again, right? And to that recursive call we are passing some values, and those values that we are passing, that means when you are passing -x in recursion, again what it passes here is negative of x that was here. Here it was -23, so we are passing 23 because minus of minus becomes plus. And y we are passing as it is. So whatever y we received, we are passing as it is. So here y was -48, we are passing it as -48. Now that's the call we are in. Now let's see. First line says if x is less than 0, our x is 23, it is not less than 0. So we come to else if y is less than 0, that is true, y is negative. So what we are doing, we are making a recursive call again, and this time let me call that we are putting that value as in a variable called b. Here we are putting in a, here it is b, here it will be c, here it will be d. So b's answer has to come from recursive call. So we will go ahead and make one more recursive call, and let's see what we are passing to that recursive call from here. So we are passing x and -y. Our x is 23. That is passed as it is. We are passing -y, so y was -48, and we are passing positive of that 48. So these two values go into this recursive call. Now let's see what happens in that recursive call. Now x is positive, y is positive. So first line, x is less than 0 is not true, y is less than 0 is not true. Come to third, if x is 0, y is 0, that is not true. Fourth is else, return 100 into this recursive answer. That means we have to return d. So d we have to calculate recursively, right? So here we will say our d that we have, it is equal to 100 into some answer coming from recursion. So this answer has to come from recursion. So there is a recursive call that we are going to make, and this, if you see, it's a recursive call over here up to here, and then we are doing some other jugglery around. So we will look at that, look at this D assignment later, what we are doing for D. Now let's go into this recursive call that we are making. So this recursive call we are making is, we are passing x by 10 and y by 10. X by 10 is divide 23 by 10. Division is like 23 divided by 10. If you divide integer by integer, you get integral answer. So it will give you 2. So that means we are passing x as 2. And same way y also, it's y by 10. So we are passing y is equal to 48 by 10 will be 4. So that's the recursive call we are in right now. So let's go from step 1 again. In that recursive function, when you are calling this function with 2 and 4, what will happen? So it does not go into the first case, x is not less than 0. It does not go into the second case, y is not less than 0. It doesn't go into third case because x and y both are not 0. It goes into the fourth case again. That means we have to calculate some d, and that d requires a recursive call to happen first before we can calculate the value of d. So that recursive call, let's see, we are doing again x by 10. So x is 2. We are going to pass 2 by 10. That means 2 by 10 is 0. Comma, we are passing y by 10. So y by 10 is 4 divided by 10 is again 0. That's the call we have made here. When that call happens, let's go again into the last call. When x is 0, y is 0, it doesn't go to the first case, doesn't go to the second case, it does go to the third case. And third case is when x is 0, y is 0. So when this is the situation, this will return a value 0. So that means this function is going to return 0, and that return value is coming back to the previous stack frame. So we are getting a recursive answer 0. Now once we get a 0, here we will do the calculation of d. D is calculated as 100 into the recursive answer, which is 0, plus we were doing 10 into x modulo 10. So here x was 2, so we say it's 2 modulo 10 will be 2, plus we are doing y modulo 10, y was 4, 4 modulo 10, modulo operator is the remainder, so that will be 4. Right, so this is what we have got as d in this function. So in this function, d becomes 100 into 0 is 0, this is 20, this is 4. So far what we got is the value of d that we are going to get calculated after recursion will be 24. This is what is formed in this function. When the function was called with 24, 2 and 4, we calculate 24, and that's 24 is what is returned. Right, so we are returning that value. So let's get rid of this stack frame also. So what this function is going to get from recursion, we made a recursive call here. We got some answer of recursion. This answer we have got as 24. Now here also we will calculate what is the d. So d was here equal to 100 into recursive answer. Recursive answer we got is 24 plus 10 into x modulo 10. Here x was 23. 23 modulo 10 will be last digit 3. So let's get that 3 plus it is y modulo 10. So y is 48. 48 modulo 10 is 8. So what we got d here is, we got it 240 plus 30 plus 8. So it became, if we see, sorry, it is not 240, it's 2400 plus 30 plus 8. So it's 2438. That is what we are putting here in this d. This d becomes 2438, and this d is being returned over here. So this d goes back. Here we got a recursive answer coming back as 2438. Now let's see what this function call is going to do with that. Here if you see, we were waiting for b to be obtained. So recursive call is returning an answer 2438, and it's putting a minus here. So what we do here, b will be minus of the recursive answer 2438. That is what our b is. So b is calculated, and this b will be returned back to the previous function. So this stack frame will also get unwinded because there is a return statement. Now when we come here we were waiting for a. So our a call is returning. That means this is returning something negative of that is what we are returning. So we got minus 2438. Negative of that will become 2438. That is what gets stored in a, and we are returning a. So eventually this stack frame goes off and we return 2438 as an answer back.